Hello everyone. We're coming back in this video to use the Gauss-Jordan elimination method to find the inverse of a given matrix. So we're going to take the 3 by 3 matrix. We don't want to put a big matrix out there. It's going to be many steps. So basically, this is how we start. So basically, we're going to start here. We put this big augmented matrix. This is the initial setup, right? So that is A right here. And then we put on the side, the identity is size 3, right? This is identity size 3. That's the start, and the finish, we want to finish it like that. We want to finish, the identity comes here, if possible, right? If the left side becomes the identity, then whatever the right side is will be the inverse of A. It's going to be A minus 1. All right, so we're going to do that. Of course, we're going to do Gauss elimination. Gauss elimination is a very important topic in linear algebra. So hopefully this matrix will not bear like complicated calculations. So let's begin. So we have the first row, which we not intend to change. We do not intend to change the first row. So now the second row, of course, we have to replace row number 2 by negative R1 plus R2. We just subtract them basically. 1 minus 1 is 0. 3 minus 1 is 2. Negative 3 minus 3 is negative 6. And then 0 minus 1 is a negative 1. That's 1, that's 0, right? And here, for the negative 2 to become 0, we do 2R1 plus R3. So basically, I'm multiplying the row number 1 by 2 and then add them up. So we get 0 here. Negative 4 plus 2 is negative 2, right? Negative 4 plus 6 is positive 2, right? And 0 plus 3 is 2, 0, 1. All right. So, all right. So this one will get some fractions, not like some crazy fraction, but it will have some fraction, because now if you go to the next step, 3 here, 1, 0, 0. So my pivot, I want to make it 1, so I do 1/2 of R2. I divide the row number 2 by 2. It's going to be 1, 0 here, 1 here, negative 3, negative 1/2, positive 1/2, and 0, right? So basically, and then this one is 0, negative 2, 2, 2, 0, 1. All right, so what I do now, I want the negative 2 here to become 0. So I'm going to have 1, 1, 3, 1, 0, 0, right? Okay. 0, 1, 3, negative 3, and then negative 1/2, 1/2, 0. Okay, now I do 2R2 plus R3. Basically, I'm multiplying R2 by 2 and then add them up. So what I get 0 here is not lost. Negative 2 plus 2 is 0. 2 minus 6 is negative 4. And then 2 times negative 1/2 is negative 1. And 2 plus negative 1 is positive 1, right? 2 times 1/2 is 1. 0 plus 1 is 1 here, and here 1. All right. So now, as you can see here, like I said, this one will have some calculations. So I have here a negative 1/4 of R3 to make it a 1, 0, 0, 1 here, negative 1/4, negative 1/4, negative 1/4. So I have 0, 1, negative 3, negative 1/2, 1/2, 0, 1, 1, 3, 1, 0, 0. Basically, as you can see here, I'm trying to follow basic Gauss elimination steps. I'm not trying to use some rules or some techniques or something, I'm just trying to follow basic Gauss elimination steps, so which I recommend you to do, All right, so now I'm going to take care of the third column. So basically what I do negative 3 R3 plus R1. So to make it a 0 for this one right here. So it's going to be 1 here, 1 here, and here negative 3 is going to be 0. All right. So now we'll have fractions, of course. So basically we multiply the row number 3 by negative 3. It's going to be 1 plus 3/4. 1 plus 3/4, which is 7/4. 0 plus 3/4, and then 0 plus 3/4. All right. So this one we do positive 3 R3 plus R2. What we get? We get 0 here, 1 here, and here 0, of course. So now again, we have some calculations. Positive 3 times is going to be 1 minus 3/2, which is a negative 1/2. 0 plus 3/2, which is 3/2. And 0 plus 0, which is 0. No, I'm sorry. So you see, I'm multiplying the second row. That's a mistake. Scratch that. It happens, It happens when you repeat steps, you can get, little bit, you can do mistakes. Is 1 minus 3/4, because we are multiplying the row number 3 by 3. 1 minus 3/4, this is 1/4. 0 minus 3/4, which is negative 3/4. And 0 minus 3/4, which is negative 3/4, right? And the row number 3 is unchanged. 0, 0, 1, negative 1/4, negative 1/4, negative 1/4. All right, so finally, the very, very final steps. So to make this one 0, okay, this one needs to be 0 using row number 2. I got negative row number 2 plus row number 1, which I'm going to change it for row number 1. So 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. So basically, I'm subtracting row number 2 from row number 1. So 7/4 minus 1/4 is 6/4, which is 3/2. 3/4 minus negative 3, which is 6/4, which is 3/2. And 3/4s are the same, 3/2. So 0, 1, 0, 1/4, negative 3/4, negative 3/4, 0, 0, 1, negative 1/4, negative 1/4, negative 1/4. So I'm done. You see, this identity in the left side, this is going to be the inverse of A. So then I say A minus 1 is the matrix 3 half, 3 half, 3 half, 1 over 4, negative 3 over 4, negative 3 over 4, and then negative 1 over 4, negative 1 over 4. That is the inverse of a matrix. It's very easy to do mistakes when we do Gauss elimination. So obviously when I grade consistent steps. Of course, it's very important to have the correct answer, but a correct answer without consistent steps doesn't mean nothing. We always learn the process. We learn the process, we do it good, and if you do a mistake, it's going to be just viewed as a mistake. And then I advise you when you do that to communicate what you're doing. You say, write what you're doing, all the steps, because the reader of your copy must see exactly what you're doing on each step. It's going to make the grading easier. All right. So this is just an example on how to use Gauss-Jordan to find the inverse of a matrix. And of course, for our exam number 1, we need to know how to do all these steps. Thank you.